number 8. Classify each of the characteristics as lock, induced fit model, or both. 1. Active site is rigid. 2. Enzyme is substrate specific. 3. Substrate shape is modified. 4. Active site is flexible. 5. Enzyme returns to initial shape after catalysis. And 6. Active site substrate interaction induces an optimal fit for catalysis. Okay, so first I'm just going to give a definition of both models. So for the lock and key, this is when your substrate perfectly fits your enzyme. And your enzyme doesn't change. So that makes sense, because that's how a lock and key works. And then on the other hand, with induced fit model, this is when your enzyme will change. To either join your substrate or break it down. Okay, so now I'm just going to make 3 columns. The first is the lock and key model, induced fit, then both. Okay, so let's look at option 1. Active site is rigid. So basically that means that the active site can't, it's not easy for it to change its shape. So this is an example of a characteristic of the lock and key model. So 1 goes there. Okay, so let's look at 2. The enzyme is substrate specific, so this can be both of them. Okay, so now let's look at 3. The substrate shape is modified, so we know that this is induced fit. For active site is flexible, again, we know this as induced fit. Five, enzyme returns to initial shape after catalysis. So this is actually a characteristic of both of them. Since even for lock and keys, since it doesn't change anyways, so it is its initial shape. And then lastly, 6, active site substrate interaction induces an optimal fit for catalysis. So this is the example of induced fit model. Even the word induces is in the sentence. So pretty straightforward question. Let's see the answer from our junior tutor. Lock and key, active site is rigid. Induced fit model, active site is flexible. Active site substrate interaction induces an optimal fit for catalysis. And substrate shape is modified. And then for both of them, enzyme is substrate specific and enzyme returns to its initial state after catalysis. So this solution is correct. Okay, so now